Welcome to my YouTube channel Love Physics, and today I'm going to discuss lens maker's formula. As you know, lens is made of the two refracting surfaces. So there will be the two refracting surfaces of center of radius of curvature R1 and R2 respectively. So first of all, we draw a diagram for this lens. Let us consider we are having a lens as convex lens, and there will be this is the optical center C, and there is a line which is passing from this optical center is known as the principal axis. You can see. Now let us consider that we have an object O here, and the light is incident and on this way, and if the refraction is only, we are having the two surfaces. Let us consider this is the surface 1 and this is the surface 2. There are the two surfaces, and this is the rarer medium, and this inside this there is the denser medium. For rarer medium we are having refractive index mu1, and for denser medium we are having refractive index mu2. Now if there is refraction through the one surface only due to surface number 1, then we have an incident light, we have a refracted light like in this way, and here we will get an apparent image which will be suppose I dash, and if the refraction goes occur due to the surface 2, there will be refraction here, and let us consider this is the image I, and we are getting image I here due to the refraction of the surface number 2. Now if this is the optical center, this is the pole 1 and this is the pole P2, we are having two center of curvature. Let us consider one center of curvature is here and one is here. Due to the center of curvature of the second surface, here will be C2, this in this way, and the C1 and the fourth surface number 1, we are having center of curvature here as C1. Now you can see from optical center, if we observe the distance I, this is the distance, actual distance V, image distance of image from the optical center, and if we note down the distance of apparent object from optical center, we consider that this is the V1, and from the optical center to O object the distance is U. So here we can see U is the O used for the object distance and V is used for the image distance. Now what we have to see, first of all we have to see there is the refraction which is passing through the two surfaces. Let us take through the surface number 1, where the refraction occurs from rarer to denser. Refraction occur from rarer to denser, and for this we know the formula. There is the formula which is denoted by mu2 minus mu1 divided by 1 by mu2 minus mu1, and this is mu2 minus mu1. Mu2 minus mu1 is divided by radius of curvature R, and this is equal to minus mu2 divided by U plus mu1 divided by V. So this is the formula for the refraction from the rarer to denser. This will be the mu1 and this will be the mu2. This is the formula for the refraction from rarer to denser. If we talk about but see here in the according to the diagram, if we go from rarer to denser medium, there is the R1. This is what is distance from C to C dash. This is the distance. This is the distance R1, and this is the distance R2. Correct. If we are going from rarer to denser, there will be the radius of curvature r1, as you know, and the for the distance will be the same u, and image distance will be the, if we are talking only surface 1, the image we are getting I dash, and so the distance will be, distance of image from the optical center will be v dash. So we will write in this way. Now we talk about the through surface 2 and the refraction here from denser to rarer, can be written, put mu1 in place of mu2, and in place of mu1 we have to write mu2. And as you know, there is, if there is r1, this is the r1, when we go refraction from the denser to rarer, what will we take the this radius of curvature as r2, and this will be equal to mu1 by u. Here what will you see, mu1 will be converted into the mu2, and u will convert into the, as what is here the final image, this image will behave as a point object here, and the image, this is mu2, this will be converted into mu1, and v dash will be converted into the actual v, which is the final image. So this is the equation 1 and this is the equation 2. You have to add these equation, adding equation 1 and equation number 2. What can you see? If you add these two equations, mu2 minus mu1 divided by r1 plus mu1 minus mu2 divided by r2, and if you combine these two equations, this will be mu1 by u plus mu2 by v1 minus mu2 by v1 plus mu1 by v. You can see here these two terms will cut when we combine these equation 1 and the 2. Now here you can see mu2 minus mu1, and here is mu1 minus mu2. So put common as mu2 minus mu1 outside of this, and it will be 1 by r1, and here there will be negative sign left, so it will be minus 1 by r2. And if you take mu1 common here, this will be minus 1 by u plus 1 by v. Now take this mu1 here, mu2 minus mu1 divided by mu1, 1 by r1 minus 1 by r2, this will be equal to minus 1 by u plus 1 by v. Now you can see here this mu2 minus mu1 will be divided by mu1. If you divide these two equations, you here see mu2 divided by mu1 minus mu1 divided by mu1 will be equal to 1. Here you can see. So this is the 1 by r1 minus 1 by r2, and this will be equal to minus 1 by u plus 1 by v. If you divide these two equations, mu2 divided by mu1, you will see here this will be mu minus 1, and this will be 1 by r1 minus 1 by r2, and this will be equal to minus 1 by u plus 1 by v. But if you take mu minus 1, if you take u as infinity, negative infinity, and v is equal to plus f, it means if you place an object at infinity, if you place an object O at infinity, then the image will be, we will get on the focus, so this v will be at the f. Now if you put here mu minus 1, what you can see, this term will be mu minus 1, 1 by r1 minus 1 by r2, and this will be equal to 1 by f. So this is the formula. This is the formula which is known as Lensmaker's formula. I will write this formula again here. Mu minus 1, and this will be 1 by r1 minus 1 by r2. This will be equal to 1 by f. This is the, dear students, Lensmaker formula, known as Lensmaker formula. So I'm going to repeat this term, this whole derivation once again. Here you can see the diagram from rarer to denser. Here in this diagram, what we will see, the light is going from the rarer to denser, and then it is going from denser to rarer medium. So we talk about the two surfaces, surface 1 and the surface 2. In the surface 1, you are seeing, you can say the refraction is from the rarer to denser, and there will be the formula in such a way. Now for the surface 2, if the we want to know the formula for the denser to rarer, put mu2 as mu1 and mu1 as mu2, and R1 is R2. So we interchange these terms, and in place of U we have here V1, and in place of V1 we have here final image distance, which is V. So when we combine these equation 1 and the equation 2, we obtain the result in such a way, and this will be the result. And if you take one assumption here, that if the object is placed at the infinity and you are getting the image at the focus, then put here in this formula U as the minus infinity and V as the plus F. Then you will see the formula will be in this pattern: mu minus 1 bracket 1 by R1 minus 1 by R2 will be equal to 1 by F. So this is the lens maker's formula. Thank you so much.